In this section, we're going to very briefly look at image layers. Now, a lot of this will make a lot more sense when we talk about Docker files in a later section, but I just wanted to briefly mention it. So this command, docker pull nginx, if I run this now, because we've already run it before, this won't take very long at all to run. And as it says here, image is up to date. If I run docker rmi nginx, so if you remember, this removes the image. Now you can see this has deleted a whole bunch of things and it's removed some tags, which we spoke about in the last section. So I no longer have the nginx image on my system. If I now run pull nginx again, it's going to pull those images down. Now one thing you'll notice, it's not downloading one thing. We've got a list of 7 things here. Now if you run another command called docker inspect, this is going to inspect the image and dump out a whole bunch of JSON. And you'll notice that it's got a whole bunch of layers here. So the layers we saw before, like 7 layers. Switching over to the Docker desktop GUI that we saw when we were installing Docker a while back, then if we go to the images section, and then do you remember when we drilled down on an image and we saw this user interface? So we can see here we've got image hierarchy, we've got a whole bunch of image layers. So all of these things like copy, env, label, we'll talk about that when we get to Docker files, but each of those are individual layers. And most images are derived from a base image. And typically that's a container OS image, something like Debian or Ubuntu or something. And we can see this in the image hierarchy. Again, this will make a lot more sense when we talk about Docker files. So looking at a very quick diagram here, we can see from bottom to top, we've got the layers stacked. We've got this base image layer. This can be a container OS, something like Debian or Ubuntu, and then the other image layers build on top of those. So those are deltas, those are changes that we make to the base layer. And each of those layers are read-only. I've got the container layer on the top, but this isn't really part of the images. This is when you spin up your container, and that's writable. That's not read-only like the other 2 are. One thing to point out with these are they are cached. So as we saw before when we did the Docker pull and it grabbed 7 different layers, each of these are individually cached. So if a base layer, so for example Debian, has already been downloaded by one thing, and another thing uses that same base layer, then it's not going to download it twice. So for example here, if we've got the Debian base image and the Node image uses it and the .NET images uses it, it's not going to download Debian twice. But as I say, all of this will make a lot more sense when we delve into Docker files. But first though, before we build our own Docker file, the next section we're going to build our own application that we can then package up using Docker files to build our own images. In this section, we're going to build our application that we're going to package up in Docker images so that we can run them as containers. As we said earlier, a Docker container is typically just for one thing. So our front end will be one container, our API will be another, and we'll also spin up SQL Server in another container, just as we've already done in this course. We'll be using .NET for both the front end and the API. If you're not a .NET developer, then that doesn't matter. It's a similar concept if you were building a web front end and an API in another language or framework. And you might find it interesting anyway to see just how easy it is to create stuff in .NET nowadays. The front end technology will use Blazor WebAssembly, which is a SPA framework and has a very similar SPA paradigm to Angular, Vue, and React. And the backend technology we'll use is ASP.NET Core Minimal API, which has a similar-ish feel to Express in Node. One reason we're creating multiple things here is that I want to use it later to show how to run multiple containers with a single command using Docker Compose. Okay, so let's get started. So first up, let's create our front-end application. So this is using JetBrains Rider, and I'm just going to create a project called Docker Course Frontend. This is a Blazor WebAssembly application, so this is like a SPA application. I'm going to choose Docker Support Linux, even though at the moment we're not going to use it. All this will do is create a Docker file. So if we run this application, then straight away we get up our Blazor application. So very, very simple. Now, because we want to make an outbound call to our API, the first thing we need to do is inject HTTP client. And it's very similar to a lot of SPA frameworks like Angular. So if we do this, inject HTTP client, and then we can get rid of this bit. We basically need a button we want to click, just a way of interacting. And GitHub Copilot has actually suggested something for us, which let's go with that. And we're going to return a list of podcasts. So I'm going to call the button Get Podcasts, and we can create a handler called Get Podcasts. If we create this method, let the ID do this for us. It's put the code behind at the top for some reason, so I'll move it to the bottom, which is where it's normally kept. And then we're going to call our HTTP client. We're going to get some JSON, return a list of string, because we're just going to return a list of the podcast titles. And then GitHub Copilot has suggested this for us, so that'll do. We don't need the API bit, let's get rid of that. And let's make it HTTP only, just to keep things simple for this demo. And then we need to await that, make it awaitable. And we need a backing field, podcasts. Let's move that up a bit. It's yellow. Oh, it's nullable. It needs to be nullable. Cool. And now we just need to render that out when we click the button. So, oh my goodness. GitHub Copilot has got it bang on pretty much. That is what I wanted, so let's go with that. So yeah, if we accept that, just one small change I'm going to make, and I prefer the is null syntax, so let's change that. And that looks good to me, so I think we've done the first bit. So this, when we run this, it's going to have a button, it's going to make a call out to a web API, which we'll create next, and it'll display a list of the podcast titles. So now let's create the web API. So again, in Rider, I'm going to call this Docker Course API. And instead of a WebAssembly Blazor, we're just going to choose empty because we're going to use minimal API. So a really easy way of creating APIs in .NET. If we go to program, then we can see how basic this application is. If you've used something like Express, it's going to look very familiar. We've just got an endpoint here, which is currently returning hello world. That's all it's doing. But we want to return a list of podcasts. So if we change the endpoint to be podcasts, and then instead of returning a string, we want to return a list of string. And we're just going to hard code for now a bunch of podcasts. Now, obviously for this first one, I'm going to choose my own podcast, the Unhandled Exception podcast. And then we're going to let GitHub Copilot choose the rest. So it's picked Developer Weekly, good choice. Stack Overflow podcast. The Hanselman's podcast, Scott Hanselman's one. I'm also going to choose next .NET Rocks podcast. That makes sense. We're writing in .NET after all. The Azure podcast, that'll do. We'll just do a few more. AWS. So this is all GitHub Copilot choosing these, not me. The Rabbit Hole podcast, don't know what that is. And I'm going to manually add this one, the .NET Core podcast, because otherwise Jamie, the host, is going to be upset at me. And if I've missed anyone off, blame GitHub Copilot, because obviously I can't go on creating a list of all the podcasts. There's a lot of awesome ones out there. So if I run this now, we can quickly grab the port number from the bottom and then switch over to the front end. And I'm just going to update the port number here to match. And then I think we're good to run it. Let's give it a go and see what happens. We've got a button, Get Podcast. Let's try this. Oh, it wouldn't work the first time, would it? Let's see what this is. This is a CORS error. Right, okay. So if you're not familiar with CORS, this basically is a security thing. So where you've got a web front end and an API and they've got different domain names, it just basically protects what can call what. This is a demo. So I think for this, I'm just on the API going to turn off CORS or allow any source origin. So let's do that. So if we go to the API, go to programs, if I can remember how to do this, it's in builder, services, add calls. So I've got to enable calls here and then use calls. And I'm going to tell it to allow any origin. And I think that should do it. So if we rerun this now and then go back to our Blazor application, I don't think we need to rerun this actually. We can just go back to the web page and get rid of that error and try again. And perfect. So we now have a web front end calling a backend API, two completely separate projects, and we're going to package them up completely separately in two different Docker images. So the last piece of the puzzle is we're going to get the backend API to talk to a database instead of hard coding these lists of podcasts. So there'll be three components: the web front end, the backend API, and the database, which we're going to store the list of podcasts in. And these are going to be stored in three separate Docker containers. Normally for a bigger project, I would use Entity Framework, but to keep this super simple, because this isn't to talk about .NET or Entity Framework, that kind of thing, the easiest way to do a SQL statement is Dapr. So I'm just going to quickly use Dapr to do that. So in NuGet, if we search for Dapr and add this package, then I'm going to change the endpoint to be more function rather than a lambda, so I can add more code. And first of all, we need to create a SQL connection, which takes a connection string. This requires another NuGet package. So if we add this, and then we add our connection string. So this is the same connection string we've used before when we spun up SQL Server in Docker. And then we need to query the database. So we're going to use a podcast entity object and select star from podcasts. We need to make it awaitable. And then we can quickly create that podcast entity object. Now we're keeping this fairly simple. So we just want a primary key, an ID, which we'll use a GUID, and a string, which is the podcast title. That's all we need. Then if we assign that to a variable and return it, we can comment out that list of hard-coded podcasts that we added before. That's actually the wrong port number, so if we get rid of that, so we'll use the default port number. And then I think we are, in fact, we don't need that to be a variable, so we can just return that straight away. And I think we are good to go. So if we go over to the command line now, and you probably recognize that command from previously, we're just going to spin up SQL Server in Docker. So SQL Server is now running, nice and easy. Then if we go to Azure Data Studio and connect to it, just like we've done before, localhost, SA, and then dome train #123. We don't actually have a database at the moment, we've just got SQL Server. So the first thing we need to do is just create the database. Let's call it podcasts. We also need to create a table, which we'll call podcasts. That's a bit big. And it's just the ID and the title like we saw before. We also need to insert into the table the list of podcasts that we were previously hard coding. And then I think we are good to go. So if we run our API now, go back to the front end, restart this, although we probably didn't need to be honest. It's failed again. What's this one? So this is, oh, I know what this is. This is because the front end is expecting just an array of strings, and we're returning a bit too much. So let's just change this so that we are selecting just the title. And let's try that again. And it's now worked. So now we've got the front end talking to an API, which is talking to our database to get the list of podcasts. So in the next section, we're going to look at packaging up the front end and the API into Docker images so we can spin them up as Docker containers.